Now we're going to introduce the idea of an equilibrium. An equilibrium occurs when you have a forward reaction and a reverse reaction, and those reactions are occurring at the same rate, or at a stabilized rate. It's usually written in a way that shows there is both a forward and reverse reaction. You can see this, it's usually a double-headed arrow or a two-sided arrow, like this. Chemical equilibria are typically described as being dynamic. It's not a static situation. You have reactions occurring, reactants forming products, and then those products reforming those reactants. They just happen to be at a steady rate. These steady rates lead to constant concentrations of both reactants and products. We'll end up calculating those concentrations a little bit later. Carbonated beverages are at an equilibrium. You have a carbon dioxide, which is slightly soluble in water, and that carbon dioxide will form carbonic acid. Carbonic acid is a weak acid, so it can then dissociate into a proton and its conjugate base, and we'll talk more about that in the next module. But then it can also transfer into the reverse and form carbon dioxide and water. So this equilibrium is what causes your drinks to be fizzy. Once you open a soft drink, you are disturbing the equilibrium. So a shift occurs. We're going to talk more about those shifts in a couple of pages. But the shift in that equilibrium disrupts the forward and reverse reaction. It changes the rates that they occur. The physical change between a liquid and a gas, or a solid and a liquid, could also be described as an equilibrium. Whenever you have a phase change, you have a dynamic equilibrium. You have a rate of each phase occurring. So you have the liquid transferring to a gas, but also that gas transferring to a liquid. Or in the case of melting ice, for example, you have the solid and the liquid then re-solidifying. So an equilibrium is established when there is a chemical reaction in which the state in which the conversion of reactants into products and the conversion of products back into reactants occurs simultaneously. That's at the same time, at the same rate, and there is a state of balance. Now, this will only occur with reversible reactions. That is, a chemical reaction that can proceed in both the forward and the reverse or opposite direction under given conditions. So as we write out a chemical equation, we have reactants on the left forming products, but then we can also form the reverse of the products forming reactants.